Greetings welcome. welcome. Welcome to another nostalgic ramble about some high school mathematics. We are looking at the IEB May 2023 paper 2. Today we are delving into question 13, which is giving lots of trig. Exciting. Right, so question 13, let's go. In diagram 1 below, ABCD is the rectangular base of one section of the roof of a hut in the mountains in Lesotho. The isosceles triangle BEC will form another section of the roof. So we're told AB is 12. I'm just going to go ahead and start scribbling 12 centimeters. AD is 8 centimeters. Okay, and because it's a rectangle, we know that this will also be, I'm just going to write this in gray so that we remember to explain why, right? But so long we can just jot down our ideas. Okay, right. And then we're told that EM is 6 centimeters, okay, which is the perpendicular height of the triangle, cool. And BE is, of course, equal to EC. Well, okay, not of course. They do need to tell us which sides are equal in the isosceles triangle. Okay, so we don't know how long it is, but we know that it is EBE is equal to CE. Awesome. Then in diagram 2 below, triangle BEC from diagram 1 is folded up along BC such that it is perpendicular to the base ABCD, okay, which they have somewhat drawn in for us by drawing the triangle EMD. Yeah, okay, get the gist. Right, so question A says, when the roof is completed, BEC needs to be smaller than 65 degrees to prevent snow building up on the roof. So this angle here, okay, BEC needs to be smaller than 65 degrees to prevent snow building up on the roof. Determine whether or not snow will build up on the roof. So in other words, is BEC in fact smaller than 65 degrees? Okay, cool. So how shall we go about this? So we want to find the size of BEC, and because we've got this right angle triangle, I'm inclined to use a bit of SOH CAH TOA, on the grounds that this angle is going to be equal to this angle. So if I can find this guy, then I found this guy, then I found the whole guy. And it will be easy to find the first guy because we've got the 6, we've got this side with a bit of interesting work, so we can definitely use one of the ratios to figure out what that angle is. So in order for us to in order for us to be able to assert that this angle is equal to this angle and that this side is equal to this side, this is kind of hinting at proving that triangle BEM and triangle EMC are identical, aka they're congruent. So remember, for congruency, for proving congruency, we have 4 options that I am desperately trying to remember. We've got side, not applicable here because we don't have all the sides. Side, angle, side, not applicable here because we've got a side. We don't have this side, which would have, because we have that angle, the included angle, but we don't have the other side to complete the side angle side. We also have angle, side. We don't have enough angles. Oh, actually, we do, because we've got that angle, that angle, and this angle, and then we've got this common side. So that would be, or actually even this side, right? So that is actually perfectly fine. so we can use that. And RHS, which is hypotenuse one side and a right angle, so we could use one of those two. Let's go with angle side. Or which one is less work? Yeah, okay. I feel like they're going to be roughly the same amount of work. So in triangle BEM and triangle BEC, okay, we have that angle. So let's first say angle EMC is equal to 90 degrees because of the angles on the straight line BMC, right? And so therefore angle BME is equal to angle EMC. So that's our first angle. And then we know that angle EBM, okay, so that guy is equal to angle ECM, right, is equal to that guy. And that's because of, I'm just going to have to write the reason on the next line, base angles of isosceles triangle BEC, okay. And then lastly, so we've got angle, and then we need side. So we could use either BE is equal to EC given, or we could use EM is equal to EM because it's a common side. Okay, so either one would be fine. So EM is a common side, right? And so therefore triangle BME is congruent to triangle angle B is equal to angle C, angle M is equal to angle M, and then angle E will be equal to angle E. And again, no space to write it next to it, okay, but the reason would be angle side. Awesome. So we now know that the two triangles are identical, which then allows us to say therefore BM is equal to CM, right? You can see that from the congruency statement, but also just visually, right? And that's because triangle BME is congruent to triangle CME, right? And so therefore BM is equal to CM is equal to half of BC, which we were given to be 8, and so it will be 4 units, 4 centimeters, right? And so now knowing that this is for, oh, okay, I fell right into the trap that I tried to avoid. Okay, so remember why we put this in gray? Because it wasn't given to us. We still need to explain why. We know that BC is equal to 8, obvious as it may seem, but we are mathematicians and we are rigorous. Okay. Hey, what about the thing? Right. Okay, so we want to say BC is equal to AD, which we were given, right, is equal to 8, because opposite sides of a rectangle, right, we know that those are equal, right, perfecto. And so now we can now this works out nicely, right? Now we can say that BM is equal to CM, which is equal to half of BC, which we have found to be 8, and so each of them is equal to 4 centimeters in length, right? And so now remember we're trying to find this angle, right? So we've got the opposite side, we've got the adjacent side. We are going to use tan, right? Oh, maybe I want to shrink some things, but I'm also feeling like I made a mess. I wrote on the diagram, which is very unfortunate. But anyway, let's try. Oi, okay, too conservative. I just love how my default reaction when I have problems like these is that I need an AI. The AI would know what I was trying to do. This is me being ultra conservative. I don't think these ones are gonna make it. Yeah. I'm becoming better and better at this. No, why are you coming back? Okay, so I'm just gonna try write as small as possible. So this was E and this was in. Okay. Right. Okay. How does rubbing sometimes move stuff? Very interesting. Okay. Right, and we are continuing to move stuff. My goodness, why does this bracket not want to be part of the crew? Okay, right, and then the statement of congruency. Oh my dear Lord, what is happening? Go away! Where did you even come from? From the corner. Shocking. Okay. You know what? Life is going very interestingly for me right now. Right about now. I'm not even entirely sure. Oh, is that the top of the E? Okay. You will be demolished for your rebellion. Okay. That. Right, and then we can now. Ooh. Hand-eye coordination. And this note that I just don't even want. Golly. Do you see how I even have to do breathing exercises to interact with all of this madness? Right, okay, now we are finally at a place where I can say, right, angle, well, so we know that tan of BEM is going to be equal to 4 over 6. And so BEM is equal to the inverse of tan of 4/6. Okay, and let's see what that is, Mr. Calcs. You know, I finally master how to put the calculator away, and then all these other problems come out. Like all of a sudden, there's quick notes. Right, and I think usually the exam instruction is angles to one decimal place, right? But always good to keep values like these, hold on to them. So do I even remember how to do that? Shift store, and then I'm going to put it in here. Right, so I'm storing it in the little memory box A. Perfecto. Okay, so now we know that this angle over here is roughly 33.7 degrees. Okay, and we know that this angle is the same because of the congruency. So let's state that. So angle CEM is equal to angle BEM is equal to 33.7 degrees because triangle, let's hide this for 2 seconds. Just as I declared that I have mastered how to swipe it away. Life will humble you, you know. Anyway, so triangle BME is congruent to triangle CME. Why is it flying? Hello? Oh my goodness. Right. Okay. And so therefore we can now say, therefore, the whole angle, sorry, what would its name be? Angle BEC is roughly equal to 33,7 plus 33,7, right? Which works out to, so if I retrieve my value and add it to itself, right? So then I've got 67, you know what, I'm often just a lot more you know what, let me just tell you the truth. This is how I prefer to write these things, because it just gives me peace, like just to know when to put in which commas. Okay. So first of all, what I would say is, let's just clear this. So alpha A, okay, which is 33. So this one I don't round off. I just say 6, 9, something, right? Because, yeah, it doesn't really need to be rounded off. Then BEC is going to be equal to that number plus itself, right? And then that we saw is roughly equal to 67,4 degrees. Yeah, that makes me feel a lot better, right? So, and this is bigger than the 65 degrees that the question spoke about, right? Because remember they said, calci? Okay, I think the secret is for me to use my left hand. That seems to work better. Okay, remember they said that this angle BEC needs to be smaller than 65 degrees. So now we've just found that it's actually going to be bigger than 65 degrees. And so the snow will, in fact, build up on the roof. Interesting, right? Someone wants to talk to us about the physics of that. I'm down. Anyway, right. On to the next. So now we are told, well, we are asked to determine DEC as shown in diagram 2. So this is it's feeling like a 3D trig question, right? No, that's the wrong one. That's DEM. Oh my goodness, shocking. Right, DEC. Okay, so kind of over there, the triangle that's facing us, if you're to put on your 3D cap. And what do we already know? We know that AB is 12. We know that AD is 8. We've spoken about why this is 8. We haven't explained why this is 12. And that's going to be important because that's part of the triangle with the angle that we want to find. Okay. We know that these are congruent, the two triangles. Okay, right, and we know that this is 4, we're told that this is 6. And we also have the value of these angles. Wait, let me write it the way that gives me peace. Okay, right. And then we're asked to find DEC. So, and they've very kindly given us this triangle as a hint, I think, of what might help, because I was just thinking to myself, we know what DC is. We have to explain why we know, but we know that this is 12, right? And EC, right, EC, we could easily find because we've got this as 4, we've got that as 6, so we can use a bit of Pythag to find what that is, right? So we can find what that is. And then I think using this triangle, we could potentially find what DE is. Let me think about that a bit. So we know that this is 6. And then we have no idea what this is. Oh, but we can find out because this is remember that ABCD is a rectangle, so that's a right angle, and we know what this is. We know that it's 4, so we can use Pythag to find out what that is, and then combined with this and this, we can find what that is. And then having found the length of this, then we can use the cosine rule because we've got 3 sides in the triangle to figure out what that angle is. Okay, so again, in terms of the computations required, not a very difficult question, but it's all about figuring out the strategy to find out the value that you're interested in. Okay, so let's start with the really easy one. Let's start with DC. So for DC, we know that DC is equal to AB is equal to 12, and that is because of the opposite sides of a rectangle being equal. Okay, so we know that that is 12. Cool. Okay, and then we are going to go to EC. I think that's the next easiest one. So in triangle EMC, okay, so this guy over here, that's a terrible highlighting, but yes, you get what I mean. We're going to use Pythagoras. So 6 squared plus 4 squared. We did talk about why MC is equal to 4, right? Let's just go back up and make sure. Yes, so we said over here MC and BM are equal. Okay, cool. So we don't need to explain why it is equal to 4 because we've said so. Right, so 6 squared plus 4 squared is equal to EC squared. And that is because the awesome Pythag said so. Right, 6 squared plus 4 squared is 52. Right, and so EC, I'm just going to keep it in surd form because we're going to use these values later on when we do the cosine formula calculation. Right, so we have found that EC is 2 root 13. Oh my goodness, I didn't even check the memo for the previous answer. Okay, so we will check them all together. Right. And then now for the more involved one, we are going to find the length of ED. Okay, and remember that for ED, we're going to work in 2 triangles. We are first going to work in the triangle MCD. So this guy over here. Oh, you know, sometimes the straight line thing pops up. Sometimes it doesn't. I just feel like I'm being played. Right. So let's say in triangle MCD, okay, we know that the angle C is 90 degrees because angles in a rectangle are all 90 degrees. They're all right angles. Right, so we've got C is equal to 90, and so we can use Pythag over there. And so therefore, okay, 4 squared plus 12 squared is equal to MD squared. And that is because Pythag said so. Right, so we can't use Pythag unless we know that the triangle is right angled, right? So this is like your grade 8, grade 9 knowledge. Okay, so 16 plus 144 is 160. And if we square root that, we get 4 root 10. Okay, so MD is 4 root 10. And we know that this is 6. EM, right, is 6. So then we can move into the triangle in triangle EMD. Okay, we then have 4 root 10 squared plus 6 squared is equal to ED squared. And that is because Pythagoras said so. Okay, just going to divide these. Okay, right. That was violent. Okay, cool. Right, so then we've got 160 plus 36 is equal to ED squared, which is 196. And so ED is equal to 14. Okay, right, perfect. So we have successfully found the length of this guy, 14, the length of this guy, 2 root 13, and the length of this guy, 12. Meaning we can now use the cosine rule to find the angle E. Right? So I'm just going to redraw this here for reference. Okay, so we've got E up here, C and D. So this is 14, this is 2 root 13, and this is 12. And we're trying to find this angle. Okie dokie. So, so just to name them, this is little d, this is little e, and this is little c. Okay, and the cosine rule says, so we want cos e. Okay, so it's going to say e squared is equal to c squared plus d squared minus 2cd cos of e. And it's probably best to rearrange it up front so that you don't put in the numbers and then have to move them around. I don't know, I prefer that. So this is e squared minus c squared minus d squared is equal to negative 2cd cos e. Okay, and so that becomes e squared minus c squared minus d squared divided by minus 2cd is equal to cos of e. Okay, and then that negative could flip the signs of the numerator, right, and at the bottom we're just left with positive 2cd is equal to cos e. Okay, and then now we can plug in our values, which have very promptly disappeared. Okay, so I'm going to copy my triangle again. Oops, sorry, burp. Okay, some things are going to come along with, sadly. Okay, right. Okay, so we have got 14 squared plus d squared 2 root 13 squared minus 12 squared divided by 2 times 14 times 2 root 13 is equal to cos of e. Okay, let's just put this in a cloud. In the cloud. Okay, right. Add Mr. Calcs. Okay, so that gives us cos of E is equal to root 13 over 7, which implies that, so if cos is positive, so that could be first quadrant or fourth quadrant, but because we're dealing with triangles, we know that E is between 0 and 180 degrees, so we don't have to consider like, oh, the whole general solution. So let's see. So we know that it's going to be an acute angle. It's going to be an angle from the first quadrant. Shift cos of which is about 58 comma, okay, so this is actually 59 degrees if you round it off. Right, my laptop has died, so I can't see what the answer is. Oh, has it not died? It has died. Okay, so we are just going to tell you what. I am going to wrap up the video here, and I will, in the description, confirm whether the answers did in fact match what was on the memo. Yeah, if they don't match, I will do a follow-up video going through my steps, and I will link it. Cool stuff. See you on the next one.